Again, I'm given a table of values. So we have the rate at which water flows into a tank in gallons per hour. So at time 0, at the initial time, there are 12.5 gallons of water flowing into the tank per hour. At 2 hours, it looks like the rate is getting faster, so there's 13.4 gallons coming in per hour. Okay, the first question is, we want to come up with a Riemann sum approximation to approximate this definite integral. Again, I don't have an equation for R of t, so I can't come up with the exact area underneath the curve, but the idea is I'm going to use midpoint rectangles to come up with that approximation. So I'm not going to get an exact value for this definite integral, but I'm going to come up with an approximation. So remember, we have to use the numbers in this table. So my first rectangle is going to go from here to here. So the width of my first rectangle is 4. And remember, we're doing a midpoint, so I'm going to pick the height in the middle. So the height is going to be 13.4. Your second rectangle is going to go from here to here. So again, width is 4. The middle height is going to be 14.3. Plus, the last rectangle is going to go from 8 to 12. Again, width is 4. The height in the middle is going to be 14.8. If you punch these numbers out, you get to 170. Okay? Let's think about what this represents. The units on this is gallons per hour. The units on dt is hours. So notice what you're doing is you end up with total gallons. So remember, when you integrate the rate, it gives you the total amount. Okay. Now we want to be able to explain what this answer means. So when they ask you to explain a definite integral, I always start with the bounds. So remember, these numbers match up with the dt, the variable integration. So this is saying from t equals 0 to 12, always include units in your explanation, hours, 170 gallons of water. So I explained this, now I explain what this number is. 170 gallons of water are doing what? Are flowing into the tank. Okay. Next, this time they actually gave me an equation for the rate of water flow. So this is the rate. So this would be gallons per hour, where the positive rate P is measured in gallons per hour, time is measured in hours. I want to come up with the average rate of water flow. Again, anytime you guys see that word average, you should be thinking 1 over b minus a times the integral of that function. So I'm going to do over the 12-hour time period. So this is my 1 over b minus a. And we're going to go from 0 to 12. And remember, whatever comes after the word average is what you're integrating. I want the average of the rate of water flow. This equation is the rate of water flow, so this is what I'm going to integrate. Okay, now this we're going to punch out on your calculator, so you can use your calculator to do the integration, and you should get to 14.1. Now let's think about what the units here are. Again, the units here, it told me it was gallons per hour. So the units here are gallons per hour. The units on dt are going to be hours. So when you integrate the rate, you will get total gallons, but then notice here we're dividing by time again. So you're dividing by hours again. So this is gallons per hour. So this answers the question. On average, over those 12 hours, the average rate of water flow is 14.1 gallons per hour, and that seems to be in line with these numbers that are given in this table.